Hello, Mr. Luong. This is my FRQ number 10. So for part A, I'm going to draw over on the side because I don't think there's enough space for me to draw everything there. Okay, that's a good enough mess. And now I'm going to draw the forces acting on it, which are F, Fg, which looks the same as Fn because it's just sitting on the surface. Then there's also Fk. For part B, oh, you want to look at it? Here, this is what I got for that, for part A. And for part B, I have to find Fk. And I know Fk is mu k times Fn. So then I just plug in what I know, which is mu k, you gave it to us, which was 0.2. And Fn is just going to be mg, which you gave because Fn equals to Fg, and the Fg you gave us was, what was it, 44.5 newtons. Yes, so then Fg equals Fn, so then I plug in 44 equals 44.5. Everything multiplied together equals to 8.9, but this is friction. So then it's going to need a negative sign in front of it because it's acting against the motion. And for next question, before I go solving into it, I'm going to find mass first. So I know Fg equals to mg. Now 44.5 equals to m over g to get m. Then m should be 4.5 for a kilogram. So then to derive an expression for dx dt, which is, I think, is asking for velocity formula. And then velocity formula, I can do integration of a of t. And I know I can use this because the forces acting on it, because let's do net force equals to ma, right? In this case, all the forces acting on it are F of t, which changes, and then there's Fk, which does not change, and then there's m, and then a that changes, so there's t right there. So then to get a of t, I'm going to divide both sides by m to get, so a of t is going to be, here, let me just write everything out. 8t squared minus 8.9 equals to 4.54. A of t, divide both sides by 4.54. So a of t is going to be 1.76 t squared minus 1.96. And like I said before, how dx dt equals to v of t, which equals to integral of a of t. So then I can do, here, let me just put 1.76 t squared minus 1.96 dt. Okay, so then I do integration. So dx dt, I'm just going to write v of t from now on, is going to be 1.76 t cubed over 3 minus 1.96 t plus 4, because you gave us an initial velocity of 4, so that constant is going to be 4. So then I simplify further, you get 0.59 t cubed minus 1.96 t plus 4. And then that is the expression for dx dt. I can rewrite it right here. 0.59 t cubed minus 1.96 t plus 4. There you go. Okay. Oh, why is that working? Okay. That was part B? No, that was part C. Now for part D. I'm going to just plug in with what I got before for this formula right here, because dx dt equals v of t. So then v at 2 seconds, the instantaneous velocity of the block at 2 seconds is going to be plugged into the formula. So then you should get v velocity at 2 seconds to be 4.78 meters per second. And then for part E, I know x of t is going to be the integral of v of t dt. And then I plug in with what I know, because I want to find the time when the block is at 2 seconds. And to do that, I need the x of t function. So that's why I have to integrate the velocity function to find when at what time the position will be at 2 meters. So then integral of 0.59 t cubed minus 1.96 t plus 4 dt. Excuse me. And then integrate that. It's going to be 0.59 t4 over 4 minus 1.96 t squared over 2 plus 4t. So then there's no constant because, there is a constant, but the constant is 0 because you gave us the initial position is 0. So I don't need to do a number for the constant. And then I simplify that further. It's going to be 0.15 t4 to the power of 4, 0 minus 0.98 t squared plus 4t. And then I'm going to find when this whole position function equals to 2. So then I'll find when it equals to 2. So I just graph it into my calculator, and I graphed them to find the intersection point, and I got that they both intersected at t equals to 0.578 seconds, and I'm going to set this time equals to a, because I'm going to use this time to plug back into my velocity function to find the velocity at this time when the position is equal to 2 meters. So then v of a is going to be 0.59 a cubed minus 1.96 a plus 4. V at a is going to be 2.98 meters per second. And this is the velocity when the position equals to 2 meters. Okay, so for part F, I have to find the average speed for the entire 8 seconds of motion. And I know average speed is going to be basically average velocity because it's going in one direction. It's not changing direction or anything. So I know I can just do average speed equals to delta x over delta t. And delta x is going to be the integral of velocity function dt over delta t. So I can, and to find average velocity or average speed for 8 seconds, I need to do from 0 to 8 v of t dt over 8 minus 0. And then I just use my calculator. I put in the velocity function. Where's the velocity function? I put this in as a velocity function. And then I use my calculator, the integration mode. And then I got, hold on. And then I got, wait. Sorry, I have to redo this. Just to make sure. So it was 573.44 over 8. Then the answer should be 71.68. So the average speed for 8 seconds, for an entire 8 seconds, is going to be 71.68 meters per second. Okay. And now there is part G left. Part G. Oh, I didn't really like doing this, but it's okay. So this is the x-axis and this is the y-axis. And before here, let me do 1, 2, 3, 4, 5, 6, 7, 8. And I'm just gonna find the velocity at all these times so it can help me what is it called? Plot the coordinates. Yes. Okay. V at 1 is going to be 2.63. V at 2 is going to be 4.8. V at 3 is going to be 14.05. V at 4 is 33.92. V at 5 is 67.95. V of 6 is 119.68. V of 7 is 192.65. V of 8 is 290.4. And then I'm going to plot the y, which is y-axis, by 20. So I'm going to start with 20, and then I'm going to end with 320. So then V of 1 is like really, really small. So I don't know, like draw extremely small right there. Oh, should I do another color so it's easier to see? Yes, let's do blue. Okay, right there. And then the other one is gonna be small too, but just a tiny bit above. I don't think this looks very accurate because it's my best shot because this 20. That's a big number, but it's okay. Okay, let's keep going. 14.05. 14.0 is gonna look closer to 20 than before. And then next one, V of 4 is 33.92. 33.92. So like somewhere around here. I don't know, probably there. And then the next 67.95. Okay, 30, 40, 60, 67 point, somewhere around there. Yes. Oh no. So 40, 60, oh, it's right here. Right there. 40, 60, yes, 67. Oh no, maybe a bit down more. Right there. And then next one is gonna be 119. So 119. So 40, 60, 80, 100, 120. So 119 is gonna be closer to there. The next one is 192. So 120, 140, 160, 180, 200. So then 6 is gonna be somewhere around up here. And 7, oh, did I skip a number? 1, 2, 3, 4, 5, 6. Huh? Oh. 1, 2, 3. Did I skip 33? Oh, I skipped V of 3. Oh, sorry. I skipped V of 4. So V of 4, okay, let me do this quicker so you don't have to watch this any longer. I'm sorry. V of 4 is going to be right here. And then V of 5, like I said before, like 40, 60, so somewhere around there. And then 6, 119, so 40, 60, 80, 100, 120. Okay, right there. 192, 120, 140, 160, 180, 200. So then right there. Last one, 290. 290, 300, 300, 280, 290 is going to be like a bit above there. Okay. Now that's done. Now I just need to connect the dots. Okay, that is the velocity graph. Okay, I think